Welcome to the Deep Dive. We unpack complex topics, make them accessible for you. Today, we're diving into a really fascinating energy challenge. It's not happening in some high-tech lab, but out in the Northern Mariana Islands. Imagine, if you will, an energy source that actually thrives when the sun isn't shining.
Exactly. And this deep dive, it isn't just about, another type of solar panel. It's really about how a region that gets battered by tropical storms, heavy rain, how it could soon harness those exact things, the very elements that usually knock out the power grid. That kind of redefines what you'd even call a resource.
That's a powerful idea, yeah, turning a problem right into an asset. So let's paint the picture for you, our listener. The Northern Mariana Islands, they face some, well, pretty unique energy hurdles.
Yeah.
They're isolated out there, heavily reliant on imported fossil fuels, which is expensive, and they get pounded by rain. We're talking, what, an average of 2,100 millimeters a year? Plus, they're right in the middle of Typhoon Alley.
Right. And what's really kind of revolutionary here is that instead of fighting the rain, this innovation leans into it. It embraces it. We're talking about a new kind of panel, rain-powered solar panels. They use something called triboelectric nanogenerators. TELE for short. Think of triboelectric, like static electricity, generating a charge from contact, but on a really, really tiny scale, nanoscale.
Okay, 2 NGs. So a solution that turns rain, actual raindrops, into usable electricity. Wow. How does that even work? Like, fundamentally.
Well, these panels, they use special layers of electron-enriched graphene. Now, raindrops aren't just pure water, right? They carry tiny positively charged ions, things like ammonium, calcium, sodium. So when these raindrops hit, or even just cling to the graphene, it creates a kind of electrical potential difference. A charge builds up.
Okay.
And that interaction generates a current. It's pretty clever. And researchers in China at Tsinghua University, they've made some really significant breakthroughs here. They've apparently boosted the power output almost like 5 times compared to other ways people have tried getting energy from raindrops.
Yeah.
5 times. That's quite a jump. But, okay, for you listening, what's the tangible difference this makes? Say, in a place like the Northern Mariana Islands, especially when you stack it up against the traditional solar panels we all know.
Yeah, that's the key question, isn't it? It really brings up resilience, true resiliency. Traditional solar panels, their efficiency plummets in the rain. They offer maybe moderate grid resilience at best.
Right, you need sun.
Exactly. Hybrid systems, they do a bit better, sure, but they still often lean heavily on battery backups when the clouds really open up. But these rain-powered ones, they show moderate to even high efficiency during rainfall. And that means potentially high resilience overall, which is absolutely critical in a place that sees events like, Super Typhoon Pongsona.
So it's not just about generating power sometimes, it's about reliable power, potentially even when the weather is at its worst. That level of resilience, that sounds like a game changer for an island economy. But is there a catch? What about getting this tech actually deployed, especially for, say, a developing economy like the Marianas? What are the hurdles?
That's a really vital question. Look, the basic science, it's solid. And those Tsinghua results are exciting, but the main challenges right now, they really revolve around scaling up commercial mass production, making them affordable, and also long-term durability, especially in those harsh, humid, salty, tropical environments. We need to see how they hold up over years.
Okay, so manufacturing and durability.
Yeah. But the potential upside, the advantages for islands like these are just huge. You're talking reduced dependence on those expensive imported fuels, continuous energy generation, sun or rain, much greater resilience during typhoon season when the grid is most vulnerable, plus, potential for local jobs, maybe lower energy costs down the line. It ticks a lot of boxes.
Okay, let's make it more concrete.
Sure.
You mentioned a hypothetical installation on Saipan.
Right. Imagine, say, integrating maybe 200 of these rain-powered panels into a project. Let's put it at the Capitol Hill government complex. A 500-kilowatt system overall. Estimates suggest a project like that could produce around 750 megawatt hours annually. And get this, roughly 20% of that total energy, so maybe 150 milliwatts, could be generated specifically during rainy conditions.
Wow.
That system could potentially slash the government's energy costs there by, say, 35% a year, with a projected return on investment within maybe 5 years.
Right.
Think about it. You leverage Saipan's, 2,250 hours of sunshine a year,
Right.
and you start getting power on those 250-plus days when they get significant rain. It changes the whole equation.
That really is a remarkable shift, taking something that was always seen as a negative, a challenge, and turning it into a consistent power source. This isn't just about the Marianas, is it? It feels like a blueprint. The real insight here seems to be about resilience through, well, redefining what you even consider a resource,
Mm.
moving from just battling nature to actually sort of collaborating with it.
Indeed. It's exactly that. This technology, I mean, it's still advancing commercially, let's be clear, but it really highlights the potential for truly integrated, climate-resilient energy solutions, not just there, but potentially worldwide. It could position the Northern Mariana Islands as maybe even a leader on a new energy frontier.
So a final thought for you, our listener, consider this. What other unexpected natural elements, things we currently see mostly as challenges, wind, waves, maybe even humidity, what could they become if we just shifted our perspective and started looking for the opportunities hidden within?